Today we're re-implementing another very important STL container, that being the std unique pointer, and it's part of the so-called smart pointers. And yeah, I'd like to show you the internals of such a unique pointer. It'll give you a better understanding of them. And let's first try to understand what makes the unique pointers or smart pointers in general so special. Well, the thing that makes them special is the fact that they manage memory for you. So you allocate resources on the heap with raw pointers, and it is your responsibility to ensure that that memory is also freed again. Now, with unique pointers, that isn't the case, because what happens is the resource is freed automatically as soon as the owner leaves scope. And that is powerful because developers forget that a lot and create memory leaks. And that is okay for short-term programs, but if you have a program that runs for a long time, then the heap will slowly shrink, which is very bad. So basically, unique pointers, they manage memory for you. And another thing they ensure is that there's no two owners to the same resource. That's why they're called unique pointers. The owner is unique, so the resource can only be pointed to once by unique pointers. Well, there is a way to omit that, but the API makes it very hard for you to have two unique pointers point to the same place. So yeah, let's try to replicate that behavior by first creating this header file, and yeah, we will make this a templated type since it's part of the STL, right? And the only real thing we'll need is the pointer to the data on the heap. So we can even take a look and check the size of a std unique pointer of any type. T is irrelevant for this, because the only thing it contains, like in our case, is the pointer to the data. So what you'll get is 8, since the size of a pointer on a 64-bit architecture is always 8. And now that we've established that, let's take a look at how the unique pointer handles construction. So by default we use make unique since it's the safer option, but when we take a look at the actual constructor, what it allows us to do is to pass the pointer to the actual data or the resource. So as you can see here, we allocate memory on the heap and we pass the pointer to this unique pointer class. And now as soon as data leaves scope, so right here, this new object is freed again. So we'll do the same by taking in a t pointer called data, and we'll set our mData field to that data. Now, as I've mentioned, it frees the memory as soon as this object is destructed, so we'll also define the destructor, and in there we'll just call delete mData. Now that we've done that, I've also mentioned how this unique pointer class doesn't allow you to have two owners of the same resource. So they do that by deleting the copy constructor. And yeah, we can basically do the same by defining them like this. So this is the signature for them. So let's say other, and let's set that to be deleted. And let's also do the same for the copy assignment operator. So let's set that like this. And now our unique pointer class has the same behavior. Now, copying is impossible. Well, you can have two unique pointers point to the same data by doing this, but this isn't something that the unique pointer class expects you to do. However, what it allows you to do is to move the data. So the move constructor is defined in a way where when you move the resource or the actual unique pointer, data2 will now point to this new int 2, and this data will now be invalid and a null pointer. So we can do the same by defining these move constructors and move assignment operator. So what we'll do is we'll say, okay, mData is equal to the other.mData, and now that the other object should be invalid, we'll hollow it out by setting the other.mData to a null pointer. And let's also do that for the move assignment operator. However, there's a bit of a difference between those, since what you'll have to do is you'll have to return, or you won't have to do that, but it's useful. You have to return the reference. So in here we'll first check, okay, are they already the same? Because if that's the case, we don't want to set the null pointer. But if they're not, we'll move them over like this, like in the same way we did with the constructor. And next to that, we'll also delete the mData, because it is possible to call the move assignment operator after the object has already been constructed. So we want to avoid leaks. And let's now also return this. And yeah, you'll see that it basically works the same. So if we include our unique pointer class and use it, let's do a bit of Vim magic. Pointer int. Let's replace that with our unique pointer class. You see that it works the exact same way, and if we try to do this, you see that we have a call to the deleted constructor. So yeah, we've basically replicated this construction logic. And yeah, we can now, another thing we should probably do is mark this as noexcept. This is good because well, I believe people do this because the vector class prefers to move stuff over copying it when transferring or allocating new memory, because if the move constructor is marked as noexcept. So let's do that, because we won't be throwing an exception in here anyways. And yeah, we can now add more stuff from the unique pointer API, such as getting the raw pointer, for example. So we can do that by just returning mData. Or there are other functions like release, which basically what it does is it sets the actual data to the null pointer, and it'll return that that old data. Or no, it's not old, but it'll return that. So basically it will move ownership, so to say. And doing something like this, for example, would be valid. And yeah, we can go ahead and create more and more of the SCL for unique pointers, but well, that's not really necessary. You know how they work, so their implementation isn't that hard. But one thing we should probably still add is this make unique function, so our own version of that, since that's the type safe version, right? So it makes stuff easier. So it's not idiomatic if you use new for the construction. So what we can do is we can define this make unique pointer. So this will return a unique pointer, and this make unique pointer is well, it's a templated type function. So it takes in a type name t. And let's also put that in here. And this make unique pointer, it takes in a parameter, like a parameter list, or an argument list rather. So we'll define a parameter pack called args in here. And what we'll do is we'll tag in these arguments, and we want to preserve their category values, so of the paths and types. So we'll do this to mark them as a universal reference. And what we'll do in here is we'll call the constructor of the unique pointer and also new the object. However, in here we'll forward over the arguments to keep track of their value categories, because if we wouldn't forward them, then they'd lose that data. So for example, some classes do different things depending on the value category. So if one would do this, so if they do this, then they might do something different than if they would pass in an L value. So that's why we have to forward that, so that we still preserve this value category of L or R value. And yeah, now if we try to use our own class and in here call our make unique pointer, you see that it still works completely fine. Now the last thing that's worth mentioning is that the unique pointer class in the SCL, it defines these operators like the arrow operator to basically return, for example, the pointer to the data, so that people can still use them the same way they do with regular pointers. Because well, if this was a destructor, some kind of class with public fields, we'd be able to do this, and that should also be possible for regular data. So they overload these two. For example, they also overload this, and yeah, that's, I guess, worth mentioning if you try to replicate that completely on your own. But yeah, that's pretty much it. We've properly implemented the unique pointer class, and yeah, bye bye.